Over 26 years ago, back in 1997, the IBM AI Deep Blue beat then reigning chess world champion Garry Kasparov in chess. This historic moment showed that even 26 years ago, AI was actually superior to us humans in some ways. Since then, new chess AI like Stockfish have come out and become better and better. In fact, today, at the world's most popular chess website, chess.com, Magnus Carlsen, which is the best chess player in the world, is rated at around 2,865, while Stockfish is estimated to be around 3,500 rating. Well then, you may say, why is AI so good at chess? Well, other than the fact that AI has become so much more capable the past years, chess seems to be almost made for AI to be very good at. And this is because of a couple of factors. Number one, chess is deterministic, so there are rules set in place and it's impossible to break those rules. To use an analogy, this would be like if in traffic, no car could ever speed or run a red light. And it would make traffic so much easier for both us and AIs. Number two, chess can be simulated, so the AIs can run 1,000 games or more in its head a second and learn from those what kind of strategies work and which ones don't. Or, in the example I'm using, it can simulate future scenarios in every single game and pick the scenario where its position is the best relative to the opponent's. So I decided to make a chess AI, and it works by evaluating all possible moves it can make that turn, and then all possible moves the opponent can make in response to all of those, and then all of the moves it can again respond with to that, and then choosing the best path to take according to those evaluations. It's visualized here, and you can learn more about it in my article on the subject in the description. In this process, the AI has to evaluate the board several times. So the way it does that is it takes the sum of the value of all its pieces and compares it to the enemy pieces in all of these different scenarios. And the value order of the pieces goes from highest to lowest: queen, rook, bishop, knight, and then pawn in the end. And higher than all of these is putting the enemy in checkmate, which it will choose anytime. One interesting facet of this algorithm is that computational time grows exponentially with how many layers of moves you want to calculate before actually making a move. So imagine the AI has 20 moves to choose between on its turn, so it evaluates all of those, and then the opponent has 20 moves to each of those it can make, so the AI has to evaluate 20 times 20 moves, and then in response to that the AI can evaluate another 20 per one of those moves for itself. So then 3 layers is 20 times 20 times 20 moves, and you can easily see how this can become a huge number after not that long. So it puts an interesting limitation on the algorithm, so we can't use infinite depth. To show you the chess AI in action, I've loaded up a Jupyter notebook here, and here we can see the main part of the code. This is the AI. And then when we run this, we can choose whether to play against the AI ourselves with these 2 lines, or make the AI run against itself with this block. So because the process takes a lot of time, I've already ran it, so we'll just go through the results, and we can see it starts here with the blank board, and this is a text-based representation of the chessboard. Then it plays against itself all the way down here, and then it prints out when it's checkmate, and then we can see the black king is in mate here. So yeah. I hope you found all of this interesting and that you'd like to read further into the technical aspects of this AI in the article I wrote, linked in the description. Also, I give full credit for the design of the AI to Ansh Gaikwad. I hope I'm pronouncing that correctly. And this project is merely a reconstruction of his design. His article is also linked in the description.